Back for our second tutorial of this session from Jake Metcalf from the Data and Society Research Institute and the Pervade team. We'll be talking about engineering for fairness, and I'll just let you take it away.
Hi, everyone. I took the term translation very literally. So I operate in an odd space where I work both as an ethics consultant, as a researcher, and follow the technical materials closely. And so what I'm aiming to do for you today is translate some trends, hopefully in a language that can move across these domains. So real quick, Pervade. Pervade is a NSF-sponsored large grant, and so we have 7 co-PIs at 6 institutions. I'm at Data and Society. We're working on large empirical data sets about how stakeholders are responding to research ethics and data science. My goals today are to make the conceptual case that it's important that we get more rigorous about distinguishing between bias and fairness. And I'm going to show you how that distinction, which seems both on its face trivial, but often violated, is actually important for being able to make good engineering decisions or good design decisions. I'm going to show you some examples of some fair ML tools that are trying to navigate that space. I'm going to share some examples from the FAT research literature, and then we'll discuss how industry and scholarship can adopt a more comprehensive approach to fairness. So my central question for you: if an organization that builds or deploys algorithmic tools decides to invest in fairness as a business decision, what does that entail? Right? So, if we want organizations to be ethical, we need to figure out how to make ethics organizational. Right? So trying to couch some of these matters in terms of what makes a business decision work, right? Like, how do you actually tactically turn fairness into something that can be accomplished within a design space, I think is something that we need to work on more specifically. So 2018, of course, saw a huge uptake in technology firms talking about algorithmic ethics. Sometimes rather shallowly, but 2018 really is the year that our work is on the front page of the New York Times every week at least, right? So seeing that conversation sort of build up has, like we've seen engineering conferences with ethics panels or keynotes are now really common. It's a major change from even 2 years ago. And in my conversation with technologists and researchers, it's become increasingly clear to me data ethics in general, and fair ML in particular, are really becoming business decisions rather than just amorphous concerns. And so we need to think about how that's happening and how we can help it along. So practically speaking, that means there's a need to assign work, determine a cost, how is it going to affect revenue, justify a timeline, et cetera. And in the past year, we've seen a handful of companies roll out bias detection tools that are as part of their business services, meaning that fair ML is now actually a sales channel. And that's quite different than you might have thought about a couple years ago. So although there's now a substantial literature discussing design practices around fair ML, there's not much consideration of what it means for fairness to be part of a business plan. And that's in part because it hasn't been explicitly part of a business plan for most companies. It's not as if Xerox 30 years ago didn't have reasons to think about fairness. But in terms of instantiating a set of values as a concrete product that gets rolled out and deployed, there's something about machine learning and AI that's different than previous forms of computing, right? There are moments in the design practice where there has to be decisions that are explicitly about which values do we prefer. Now, we've invested quite a bit in thinking about the technical side of that, right? There's now a lot of very useful models, standards, right, that will help us with that technical end. But where we haven't yet figured out how the business community is going to invest in the values questions there. So what I'm trying to show today is that the distinction, getting clearer about the distinction between bias and fairness, it actually helps you pull apart those problems. Okay, so bias and fairness. What does bias mean? It's a 16th century term in English, coming from a French word that means oblique line, often used to describe or its original use is to describe the cut of fabric that goes diagonally across the grain of the fabric. Now, in standard usage today, it usually means some kind of prejudgment, right? It's an inclination of temperament. It's an inclination or prejudice against one group or person. It means to give a settled or prejudiced outlook, or to cause or to show inclination or prejudice against someone or something. Those are pretty familiar meanings, right? And I think these are common usages. And I'll return to in a minute, but I just want you to notice now how these these uses of bias already have a sense of fairness baked in, right? As inclination or prejudice against a group, right? That's actually a claim about values, implicitly about values in a liberal democratic society, right? Where we think that inclinations against a group of people are unfair. There's already a normative judgment baked in there. In statistics, of course, it means something very different. It means a deviation from the expected value of a statistical estimate, or from the quantity it estimates. It's a systematic error introduced into sampling. I think particularly in the context of building models for machine learning, it's useful to think of bias as the space between model and world, right? There's always space between model and world. That's the nature of models. But when we start talking about bias is when we say that space is so large that we can't accomplish our goal. All right, whatever we set out to build a model for, when we have a large gap, we call it bias, and that's because the model doesn't do as well as it should, right? So a classic example, of course, is something like polling for an election, and you miss all the mobile phone callers, and so you bias your set so that it's older, and that usually skews more conservative, right? And so then that bias results in you not being able to accurately predict electoral outcomes. Now, fair also has a variety of meanings, but its origin is in being pleasing to the eye or beautiful, right? If you've studied moral philosophy and aesthetic philosophy, you'd probably be familiar with the fact that those kinds of reasoning are very similar, right? You tend to be either an anti-realist about both or a realist about both, right? And so those are our claims about what would it mean for an aesthetic claim to be true or for a moral claim to be true. Is it because it attaches to something in the world, or is it because you have a subjective taste, right? If you're a realist, you think there's something out there that makes the aesthetic or moral claim true. We tend to be realists or anti-realists about both because they have similar forms of reasoning, and a lot of times we'll find that claims about goodness are very strongly attached to claims about beauty, right, or harmony, or these sort of amorphous notions of what goodness is. Now, it's when we get into machine learning and algorithms that bias and fairness, these different meanings of bias and fairness collide, right? These distinctions are kind of trivial, right? We could probably all articulate them. But yet, it's amazing once you start paying attention how quickly fair ML and unbiased ML become the same thing, right, in our discourse about it, especially in the press or coming from the corporate world. I know everyone here is a critical scholar and is incredibly precise with their terms all the time. But when you start to notice this, you'll see that in corporate spaces, these terms are highly interchangeable. But the problem is that bias as a social political bias, right, our most common usage, carries an implicit normative valence, right? It's already a judgment. It's already a judgment about what's considered to be unfair. Social bias is conceptually intertwined with social unfairness in a society such as ours that favors liberal democratic values, right? being biased is not unfair in every possible world, right? In some conditions, it might be fair. But in a world such as ours, under our conditions, we tend to think bias is automatically has this normative valence. And in FairML, we see that particularly along historical axes for such violations of these norms, right? So race, gender, et cetera. And then very importantly, it turns out that many of the conditions under which our society has been unfair can be tracked along, are computationally tractable, right? So as Manny pointed out, we have census entries, right? So race may be a highly amorphous object, but yet there are things that are written down that you can put into a spreadsheet, right? And then it becomes computationally tractable. So those are the elements that we work on in FairML because that's what we can compute. Now, statistical bias carries no normative valence. It's a context-dependent methodological error. So what I want to persuade you of is to be really consistent about this. Bias is a feature of statistical models. Fairness is a feature of human judgment values. All right. When these terms are disambiguated, it becomes possible to describe statistical bias as a technical feature of models, and fairness as a feature of human judgment about values. Therefore, resolving unfairness, in particular, in algorithms, becomes a job for building human judgment capacity in algorithmic engineering context. If we don't learn how to articulate and grapple with those human values, it becomes very hard to figure out within the formal computational models what should count as fairness. Fairness as an investment inherently requires, fairness as a business decision inherently requires investment in the capacity to navigate normative judgments. There's no way to resolve unfairness without engaging questions of values. An organizational commitment to FairML requires investment in that capacity. Think about, instead of what is fairness, instead of just looking for definitions of fairness, ask when is fairness, right? When in the design cycle do we look for the markers of fairness? When do we declare a product to have been fairly designed? Switch your language to being organizations that build or deploy algorithmic tools act fairly, rather than this algorithm is fair. Okay, so I've now bashed you with my argument. Let me show you some examples. So I'm going to just briefly discuss three algorithmic bias/fairness tools that are now out there. First, IBM Fairness 360. If you wanted to be learning IBM Fairness 360, you're in the wrong tutorial because you should be down the hall where they're talking about it right now. But I think it's actually a really fascinating project. It's quite slick if you've seen it rolled out. They have put a free version on GitHub, an open source version on GitHub. Their sort of back-end version is very focused on helping their clients interpret real-time algorithmic decisions. The GitHub version isn't as slick, but it's very useful. And they have a demo, so it was up on this site. I would show it to you as part of the presentation, but there is no internet at this conference of all conferences. And so instead, I'll show you a screenshot. So it runs you through some open data sets. It lets you choose what the protected variable would be, such as race or gender. And then it gives you some options for methods for debiasing, right? So it's going to give you these common forms of measuring bias, show you a range, and it's going to show you how the algorithmic tool you applied changes it. So something that's common among these tools is that we're now seeing fairness framed as the operator chooses the parameters, right? So if you want to be a client of IBM, using Fairness 360, IBM puts the onus on you to choose the parameters of what counts as fair, right? And so this tool that's useful for business relations, right? This is a very B2B kind of tool. In order to operate it, it means your organization needs to have the capacity to think about which form of bias is preferable. What are the trade-offs you're going to make? What is it you're optimizing for becomes a question about what your values are. A similar tool was released by Pymetrics. They're a service for resumes and the whole hiring process. Based out of New York, they released their own internal bias auditing tool called Audit AI on GitHub. That's also pretty useful. And then Accenture has AI Launchpad, which, similar to the IBM tool, is all about setting your parameters, right? So it lets you choose. Oh Lord. All right. It lets you choose what are your sensitive variables. What do you want to control for? It gives you sort of an experimental options to choose how you're going to optimize. It gives you a vision onto disparate impact, and then leads you towards some choices to make about predictive parity. All right. So Roman Chowdhury was kind enough to share some screenshots with me. This tool is pretty cool. But again, what it's doing is, she wants me to be very clear. Hi, Roman. This is a decision tool, not a fairness tool, right? So the output isn't a blinking light that says this is fair or this is unfair. The output is we are going to facilitate a decision about what you want to optimize for your product, all right? So again, fairness framed as choose your own parameters, all right? So across these tools, and there's a few more out there, but I think if you dig into those three, you have a pretty good sense of where these tools are going. So some common elements. These are tools that are being developed primarily in the enterprise or business services sector, and I think that's interesting. Right? This is fairness as a B2B concern. However, most of the conversations we have in this space are about consequences for society, right? Or consequences for individuals who are trapped in the algorithmic hellhole, right? What we tend to pay attention to are classic forms of social discrimination, but these tools are being developed as a way for making relationships between businesses clearer, right? They're not actually about fairness for the data subject necessarily, or fairness for society. They're about a form of interbusiness transparency, right? I've heard the statistic that something around 98% of algorithmic tools are left on the shelf, and that's primarily because businesses don't trust them yet because they can't see how they're making decisions, right? So this is a way that places like IBM and Accenture are trying to solve that problem. These tools draw directly on the formal techniques promulgated by the FAT community. So if you look at IBM's documentation, there's a bunch of FAT papers on there describing what are the formal models for fairness that they're adopting. And essentially, as you set your own parameters, you're choosing which model of fairness, formal model of fairness as described by researchers in this space have identified. I also see a clear trend towards open sourcing. So it's kind of a freemium thing. They're open source the source code on GitHub, and then when that big insurance company comes knocking and they want that slick back end, that's when the sale happens. But I think this is open sourcing. I think is worthy of praise because it helps build the conversation, right? It encourages other people to engage with it, even when they can't afford a giant contract with a business service company. One space that we really need to work on is mapping these kinds of tools onto workflows and decision trees. The Holstein et al. Paper, which I think is in the next tutorial session, actually has some great examples. It's a really excellent paper, and great examples of what that might look like. Okay, so let me give you 3 examples here. Oh, geez, really ate up the time fussing with the PowerPoint. Okay. Imagine that you are working at a company with a huge collection of photographs taken by users, right? So you have 10 billion photographs at your disposal. You're on the computer vision team. You are tasked with building a tool that will recognize sporting activities, right? You can think about all kinds of applications for that, right? Like automatic tagging, of course, is useful always, but also, maybe recommending stickers. So when you take that picture of your girlfriend crossing the finish line, it's going to recommend a sticker or congratulations or something because the algorithm knows that it is a photo of someone running a race. All right, so all kinds of fun, useful things that could be for. Part of the picture got cut off here. Okay, sorry. So how would you do that? You would collect, you would use hashtags, right? So you would use user-identified hashtags, 5K, personal best, marathon, et cetera, right? To find the 10 million photos that are of races in your user data set. All of those that had relevant tags, you would then process it through your computer vision algorithms, and then you would run a test set, a validation set. When you go through the algorithmic tuning process and you're looking for false negatives, you find there's a small collection of photos that are tagged 5K, personal best, marathon, that show wheelchair racers, right? Now, that could happen for any number of reasons running a deep learning algorithm, right? So it could be the shape of the upright bodies versus the triangular shape of the wheelchair racers. It could be the algorithm recognizes movement of legs as important to being categorized as racing. But now you have a dilemma, right? So now you have to decide who are, obviously we want to be inclusive. What would be an engineering solution to this?
You didn't state a problem.
A problem.
So if there's got to be a problem, there's going to be a solution.
Right. Okay, the problem is there are a fraction of users that get left out. Your company wants to be inclusive and because you value providing a excellent service to all of your users. Yep.
So you would make an effort to collect a data set that targets the users that you don't have, so wheelchair racers.
Yeah, add 10,000 photos of wheelchair racers, right? Give the algorithm something else to study, essentially. I looked at the statistics for New York City Marathon, and it's roughly about 1,000 to 1, the number of foot racers versus wheelchair racers. The wheelchair racers are much faster, by the way. They kind of murder the foot racers on time. But it's about 1,000 to 1, right? So what you're going to need to do is overload that data set. Now, would we say that the learning set is biased? Now, we could point to structural biases and say, well, maybe there's fewer racers because they don't have access to resources. Maybe fewer people take photographs of them because, there's not 1,000 people at the finish line because the sport doesn't get as much attention, right? We can point to structural reasons, but there's always going to be fewer wheelchair racers, right? So even if in a counterfactual society where there's no structural discrimination, you still might have this computational problem, right? So the solution to this isn't necessarily debiasing, it's actually arguably introduction of bias to the data set, right? It is altering the model so that it actually doesn't fit the world as well. Right? But that's because you have a commitment to equality as a company. That means investing in the time it takes for an engineer to pause the project, to tune the algorithm, to find 10,000 photos of wheelchair racing in the data set somewhere or elsewhere, right? That's an investment in a human value judgment capacity, not an investment in the structure of a data set. Similarly, You're working for a company that runs resume analysis and social networking, right? Like it might be a place called LinkedIn or something like that. You have a predictive service where if somebody says, "Hey, I'm looking to hire a divisional director," into their little chat bot, and it searches 3 levels out in the social graph. This is my very mediocre attempt to make a social graph using boxes on PowerPoint. But if you trace 3 levels out, you find that there are there's a 2-to-1 ratio between men and women, or the pink and blue circles here. So now we can come up with a lot of structural reasons why that might be the case, right? So women have had far fewer opportunities to rise up in the ranks because of sexism within the tech industry. There's a lot of structural reasons we can point to. But even without getting to any sort of fancy algorithmic tool, you still have the question about who are you serving, right? Are you serving the customer who has hired you to do this search through the network, or are you serving equality between the people who uploaded their resumes, right? So again, we come to the question of building the capacity for values in order to figure out what counts as fairness, not just doing fancy algorithmic tricks to address inequality that is embedded in the data set. Okay, I think I still have time to cover this. So the Allegheny Family Screening Tool, or the AFST, implemented by the Allegheny County, Pennsylvania Department of Human Services in 2016. What this does, I mean, it's probably familiar to many of you from some of the FAT literature, which we'll discuss. So this is a model that provides a predictive risk score when a call comes into a child welfare call screener. It provides a score 1 to 20, so in ventiles, that predicts the likelihood the child will need to be removed from the home in X months based on something like 185 variables in the data set. So this is intended to supplement human decision-making regarding whether a call should be screened in. Nobody's case is adjudicated on the basis of the score. It's instead intended to help the human call screener collect and interpret information. Right? And so the human provides a score, the algorithm provides a score, there's a decision process about what to do next. Right? Calls are either screened in, which means a caseworker goes to investigate in person, or screened out, which means this is probably not a high-risk call. Now, this draws on an extensive integrated database that includes multi-generational records of contact with county services, right? So if a kid, let's just call him Jake, is potentially being abused at home, and a neighbor calls it in to Child Protective Services, they're going to look at the records of Jake's siblings, Jake's parents, Jake's aunts and uncles, Jake's grandparents, potentially, even maybe great-grandparents, depending on who's in the data set. And they're going to look at this extensive family history, contact with county services, and all of that's going to feed into this question of, does CPS go visit? So it's developed by Rima Vaithianathan from Auckland and collaborators from her lab. Importantly, this included a pretty extensive ethics review by Tim Dare and Eileen Gambrill. I spelled it Time Dare. That's a great name. Tim Dare, who's from Auckland, and Eileen Gambrill, who's from Berkeley, in a white paper that they released from their lab. And the ethics review is worth reading. Also, it was described, this was described in, I think this was the best paper of the year last year at FAT, Alexandra Koldakova, and then Rima's lab, where they describe the algorithmic tools that they use to adjudicate fairness in this. Now, also, this was described in a chapter in Virginia Eubank's excellent book, Automating Inequality. Has everyone read that? Oh, we need to see more hands. This is a great book. You should be reading this book. All right. Okay, so Virginia this is very interesting from a scholarly perspective. She's a historian of poverty studying algorithms, right, rather than an algorithmic scientist studying poverty, right? And so her perspective is unique. It's methodologically unique here. Now, she has a whole chapter where she spends time with people in this county and discusses their experience of encounters with child protective services that has been buttressed by this algorithmic tool. And she spends time with the social workers. She describes the formation of the tool. But if you read all of these together, they're talking about like completely different things, right? You wouldn't think this is the same tool if you read these stories next to each other. It's very strange. And there's an important methodological point buried in there, right? So what's the primary concern of the people designing and deploying AFST? They want a predictive risk score that reduces harm to children, which means they want fewer false negative screen outs, without causing secondary harm through over-surveilling families. That is, they want fewer false positive screen ins. Right, so they're optimizing for less false negative screen outs and less false positive screen ins. Okay. They also spend quite a bit of time examining what is the predictive tool, how does it operate fairly with regard to race. They found leaving race out as a variable affects very little. But they described the conversation where they tried to decide, should we allow this algorithm to have access to that column in the spreadsheet at all? The primary concern of the ethics review is this tool ethically preferable to the status quo that doesn't use the tool? Right? So the ethicists are looking at a binary option. They're looking at, should we have the tool or not have the tool? Is the world better with the tool, or is the world better without the tool? All right? And then what are the governance structures we need to keep it better? Eubank's primary concern is very different. Do algorithmic social science tools exacerbate long-term structural inequality? Cui bono? Who does it benefit? All right? Does it benefit the state because it saves it money under a austerity regime? Does it benefit the children? Does it benefit child protective services? Right? This is a sociological, historical look at fairness. These are all forms of fairness, and they're all methodologically wildly different. All right? So if you were to try to answer the question, is AFST a fair product, it becomes very challenging to integrate these. We don't have great models for how to do that. Now, interesting, Virginia doesn't write about the technology very much. And although the computer scientists describe meetings with community stakeholders, there's no description of the methods, right? There's no description of how it was integrated into the design process. I'm sure it was there, but what they're trying to accomplish and the methodological standards of their discipline is different, right? So in terms of translation, we have a task here of getting these different ways of framing fairness to talk to each other. I have 3 minutes, yeah. PowerPoint, man. Never works right. Okay, so there are some great technical challenges, or there's some great descriptions of the technical challenges for formal models of fairness, including several at this conference this week. There are also some great papers describing non-technical challenges for formal models of fairness, including one recently by our intrepid host here, Luke. And I would love to describe those to you in detail, but I am not. Arvind's tutorial in 2018 posed a challenge to us, which is that we need more philosophical input regarding which mathematical models of fairness are preferable and mapping mathematical models onto philosophical traditions. Watching that live stream remote, I chuckled because that's even harder in philosophy than it is in statistics. There's enormous cultural theoretical diversity of opinions about what counts as fair. Many of them are incompatible. It's also very hard to determine quantifiable or computable ethical preferences. And formal ethical models actually run into impossibility theorems that are quite familiar, that are probably quite familiar to statisticians. such as Derek Parfit's repugnant conclusion, which is this. If you imagine any variety of goodness and make it your y-axis, so it could be pleasure, it could be tummy rubs for kittens, it could be total unicorn fluff in the universe, whatever it is that makes life good, all right? And put it on an x-axis. It turns out that a world that combines B, which is a world with a lot of suffering, and combines it with C, which is a world with just a tiny little bit of goodness for a lot of people, that has a higher quantity of goodness than A. But that seems repugnant to us, right? So which of those kinds of worlds are we going to train our algorithms to optimize for? Becomes a challenging problem. When we're grappling with these tools, when we're building out these resources within companies, we're going to have to learn how to deal with pluralism, contextualism, and messiness, all right? And those are things that require a significant amount of human resources, right? The capacity to handle values, judgments in engineering contexts is going to have to be the way that we get to fairness. One very last thing, I'm involved in the IEEE P7000 series and ECPACE, that's Ethical Certification Program for Autonomous and Intelligent Systems. ECPACE is ramping up and we're looking for volunteers who want to help contribute to the creation of, of a certification. This is about due diligence. This is really important. These standards are not, again, blinking light that says fair, unfair. These are about what would due diligence look like were one to claim that an algorithmic tool is accountable, transparent, or unbiased. Having been involved in these with IEEE for like a year and a half as the ethics chair of the P7000 standard, I can tell you these are really intellectually challenging problems. And so I would encourage you, if you're interested in this, you can ask me about it. Also, here's contact Rudy if you're interested in contributing. Thank you. I'm sorry we didn't get time to discuss.
So I wonder, I know we are at coffee break, but I wonder if we stay for 5 minutes for any pressing questions or comments. And if you need to go, obviously you can, but are there pressing comments or questions? A couple?
Pressing comment on the repugnant model. I mean, you're aware of that, but because you showed the slide, I feel the need to make the comment. This is based on a very old style, very oversimplified utilitarian notion of goodness and how to add it up. Yep. And that's been surpassed in philosophy long ago.
Parfit's...
we shouldn't claim that this is what philosophy has to offer. There's been a lot of interesting criticism and other proposals made.
Sure. I would suggest anybody who wants to track that down. So Parfit's paper is only 2009, I think. So yes, it's a form of utilitarianism that maybe isn't our preference, but Gustav Arrhenius, that's 2011, he describes 20 other impossibility theorems in formal models. So it's primarily about population axiology, which is how do we distribute goodness over a population. So while I agree, that's not how I would approach ethics, but it's important because it's a place where formality of philosophy can be mapped onto formality of problems in engineering. Also, there are some other perspectives. So Peter Eckersley, he's at PAI, just wrote actually a really interesting paper about impossibility theorems, drawing on Arrhenius, and why it's very important that artificial general intelligences are capable of handling uncertainty and pluralism when it comes to ethics. So while that might not be our favorite form of philosophy, myself, I'm more in the existential phenomenological realm. It is actually live to an engineering problem. I also point to Elizabeth Anderson. Her famous essay, What is the Point of Equality, I think is really informative for a lot of these problems. She's an economist turned moral philosopher. So she's dealing with formal questions run through the prism of open-ended questions about justice.
So
Yes.
I wanted to say, I agree with you entirely that perhaps one of the biggest concerns here is not so much the technical issues, which we can work on and figure out. You know, we can do the math, we can code the algorithms, but the process issues.
Yep.
I'm really concerned about B2B products that ignore the data subject and they're not involved in the development of the product. So it's, yes, you get all the stakeholders involved, but even then you can end up with what seems to be a failure. So it's helping us develop the capacity of engaging all the stakeholders in a meaningful way.
Yes, thank you. I concur.
There are two more questions, one at the back and then one at the front.
Okay. Yeah, related to that, about the certification process with the IEEE, I've been following that and I've noticed that in order to have access to the standards, and I don't know to what extent to the certification principles, you need corporate membership. And there are certain standards out there, like the standard for Wi-Fi, that have been kind of made free to the public because they're so critical. And I would argue the same for discussions about fairness, transparency, exactly for that reason of data subject often being left out. So what's the status of that, do you know? And what can we do as a community to push the IEEE to open up these?
Well, they are open. So standards are not open to the public until they're published. And publishing requires drafting. It's very formal. It requires drafting and then balloting and then another balloting. All right. So some of us who are involved in the project convinced them to change their business model specifically for the ethics standards. So instead of funding their nonprofit standard development, right? So this is all, they're nonprofit, but they have to fund the work somehow. So traditionally, like if you're making semiconductors, you're going to pay $10,000 for access to the standard. We have persuaded them to change this so that it's free to access the standards once they're published, so that it can be part of those conversations. And then there will be some sort of consulting model where if you want to implement it, you can be helped along. The reason you can't see the P7000 standards right now is because they're not public yet. They're being drafted. Anybody can join the working groups, though. You don't have to have corporate membership to join the working groups. ECPACE is a little bit different. That one does require corporate membership to vote. But anyone in this room could come in as a participant or observer. If you have more questions about that, I've been deeply involved and I'm happy to talk about any of that stuff after.
You talk a lot about liberal democratic systems and formal philosophical models that seem a bit Western in perspective.
Yep.
So, sort of a built-in bias there. Any sense of exploring other systems or other cultures?
Yeah.
It's all limited,
Yeah. So I've been grappling with that hands-on quite a bit in the P7000 stuff. So my group is tasked with figuring out how do we handle it. And the solution is due diligence, right? It's to not specify what anyone's values need to be, but rather to say, tell us what your values are, show your work, right? That's how standards work, is they don't tell you what your conclusion needs to be. They tell you what an end state of due diligence looks like and allows you to get there yourself. So the solution, in my opinion, the solution here is to work really hard at pluralism and contextualism without having to settle on a specific normative framework in advance. And that's possible to do, but it's really challenging. In terms of talking about liberal democratic values, I was trying to point to what bias sounds like to someone in the Anglophone tradition, right? And that there's actually a value claim embedded in it, which is why I want to see that differentiation more clearly, which is, let's get really clear about when we're talking about technical bias and when we're talking about fairness as a values state.
I've been one of those committee members, I just want to say, when you talk about standards
Yeah.
committees, and also led one of the sub-teams, and you find some of the similar situations there. So I've come to you as a political scientist, but a China scholar, so.
Oh, great.
we see that
I would love to talk to you, actually. Okay, thank you.
Okay, thank you all for your patience and running a little bit into the coffee break. Please thank Jake and